For today's lesson, we're going to look at conversions and linear equations. We want you to be able to use dimensional analysis to make conversions, write linear equations, and recognize slope-intercept form of y equals mx plus b. All right, starting with conversions. These are the different conversions that you should know. Most of the world uses metric units. Metric's pretty easy because when you're converting, you got little prefixes that help you, like century means 100, milli means 10, and so on. So you got some easy prefixes. Kilo means 1,000. That can help you. The empirical system that the United States uses is not as easy. These are ones you just need to kind of memorize and know. 1 foot is 12 inches. 1 mile, 5,280 feet, which is a difficult one to know or remember because it's not a common number. Also, 1 yard equals 3 feet. Time, everyone should know that one. 60 seconds a minute, 60 minutes in an hour, and 24 hours in a day. So with this dimensional analysis, what you want to be able to do is go back and forth between things and figure out. So example, how many seconds are in 7 hours? Well, the way we like to start you guys out is to start out with what you're looking at, 7 hours, okay? And if it's just 1 unit, you can always put it over 1, okay? And now what you want to do is multiply by those conversions. And you want to multiply in a way that gets your units to cancel out. If we want to go from hours to seconds, that's kind of difficult because not many people know how many seconds are in an hour. But if we use our middle conversion here of minutes, we can do that. So we know 1 hour equals 60 minutes. So in our conversions, I don't want to be in hours anymore. In order for my hours to cancel out, I want to divide by those and have 1 on bottom. So now we write down our conversion. 1 hour is the same as 60 minutes. Okay, this in itself right here is equal to 1 because it's the same thing, 60 minutes and 1 hour. But now what we can do is knock out our units of hours, and now if we were to multiply that, we would be in minutes. But again, our goal is to get to seconds, so now let's use the second conversion of 1 minute equals 60 seconds, and we can get there. Again, minutes are on top, so I want my minutes on bottom here so that they're going to end up canceling out. And our conversion is that 1 minute equals 60 seconds. Now when we're all finished here, we should be in seconds. It's our only unit left. So now, just a refresher, when you're multiplying fractions, you multiply all the numerator together, all the denominators together, and then divide. Well, here our denominator is very simple. 1 times 1 times 1 is 1. On top, we got 7 times 60, which ends up being 5,200. We're dividing by 1, so there's nothing to do. So then our answer comes out to be 25,200 seconds is the same as 7 hours. All right, let's try another one here. How many yards in 198 inches? Why don't you pause the video and see if you can do this conversion? All right, let's see how you did. Start with the one you know. You got that many inches. It's a single unit, so we put it over 1. Now we want to do our conversions here. I don't think we can really go straight from inches to yards, so let's use our middle conversion of feet here. So inches are on top, do we want inches on bottom? We know 12 of them are the same as 1 foot. Okay, now our units cancel out in inches. So now we need to get from feet to yards. Here's our second conversion. So we want feet on bottom and yards on top, and we know 1 yard's the same as 3 feet. Again, our units should cancel. So now multiply all the numerators. You get 198. Multiply all the denominators. 1 times 12 is 12. 12 times 3 is 36. Now if we divide that, we would get in yards. And so dividing that out, you get 5.5 yards. So 198 inches is the same as 5.5 yards. Okay, next one. How fast are you traveling in miles per hour if your current speed is 50 feet per second? Okay, so now we have multiple units here. You can see this is a rate, so you got feet per second. Okay, so we want to start with the one we know again, 50 feet per second means per 1 second. See this division sign? So divided by 1 second. That's a rate, 50 feet per 1 second. Notice now that there's 2 units. Okay, our answer is also going to be in 2 units because we want to get it 2 miles per hour. So now you want to convert feet to miles and seconds to hours in order to accomplish this. Let's start with our feet here. We can get from feet to miles with this conversion. Okay, so because we got feet on top, we want feet on bottom, and we want miles on top when we're done here. So now put in the conversion. We know 1 mile is 5,280 feet. So now our feet cancel out, we're in miles per second, but we need to get some miles per hour. So we got to do some additional conversions here with time in order to do that. Well, we can use our minutes to seconds here to get it to minutes. Okay, now seconds are on bottom over here. So that means we want to put our seconds on top here to get that to cancel out. Because anytime something's on bottom and something's on top, it's going to cancel. Seconds and minutes were our conversion. We know 1 minute is 60 seconds. Okay, doing one final one here. Now we got minutes on bottom. We want minutes on top. We want to get to hours. We know 1 hour is 60 minutes. Minutes are going to cancel. Our final answer now is going to be miles per hour like they're asking for here. So multiply everything on top. We want to do 50 times 60 times 60. Okay, that's going to give us 180,000. Multiply everything on bottom. 1 times 5,280 times 1 times 1 is just 5,280. And now we want to divide to get our answer. So on your calculator, that'd be a good one to use your calculator for. Divide that out. And it'll give you the approximate miles per hour. So it looks like it's about 34.09 miles per hour, approximately. So now we can write our answer here. Okay, in math, we use this little squiggly equals for approximate. Approximately 34.09 miles per hour. All right. This one's another one talking about a rate. This one's in the metric system. See if you can pause it and see if you can do this conversion. All right, let's check and see how you did. Speedometer says you're traveling at this one. That's the one we know, 50 kilometers per hour means per 1 hour. We want to get that to meters per second. So one conversion we're going to need is 1 kilometer equals 1,000. So 1 km equals 1,000 meters. Now we should be into meters per hour, but now we got to get to seconds. So we got a couple more conversions here. We know 1 hour is the same as 60 minutes. We can get rid of our hours, and our last one we need then is 1 minute equals 60 seconds. Again, putting it so that you always have 1 on bottom that cancels with 1 on top. Multiplying across now, our top's going to multiply to 50,000. Our bottom's going to multiply to 3,600. Divide that out, and you get your answer. And you get that it's approximately equal to 13.8 meters per second. So that's 50 kilometers per hour in meters per second. Okay, just some solving. We did a little bit of this in some of the previous lessons, but again, with solving, you want to try to get your variable by itself, looking to do the opposite. So here, we want to move our constants together. It's being added to, so we want to do the opposite, -2. Those now equal 0. Write what's left and do the subtraction here, -4. Okay, now we want to get rid of it's being divided by. It's being divided by 2, so we could times both sides by 2. Okay, that's going to get rid of our 2. So now we got -x equals -8. That negative in front we can get rid of by knowing that really this is like a -1 here. When they don't list out a number, we know it's a 1. So now we can divide both sides by -1. And we get that x equals +8, because when you divide a negative by a negative, it makes it positive. Okay, so those steps are the kind of what you're going through when you're doing some of the solving. On number 6, this one now you can see there's some division to it. It's a fraction. Okay, start by getting rid of that. If it's being divided by 3, we can times both sides by 3. Timesing is the opposite of dividing. So those cancel out. You get negative 18 over here when you do that multiplication. Now we got one step left to do here. Now we don't want to minus 8 because this is negative here, so we'd want to actually add 8. We want that to be 0. Okay, now it cancels out, and we get that n is negative 10. So you're always doing the opposite operation to eliminate it and trying to solve for the variable. A couple more here. Number 7, okay, start by going through and doing any simplifying. Left side has nothing. Right side has some multiple stuff here. We can't simplify in the parentheses, so we can't do anything there. There's no exponents, so then the next thing in our order of operations is multiply. We do have some multiplication here. We want to distribute. So we want to distribute that through. Again, remember a negative on there, really, when you're subtracting, it's plus a negative, so we want to be distributing negative 4 there. So what we end up with is 48 equals 4x. If we multiply negative 4 times 4, we get negative 16x. Negative 4 times negative 3 would be a positive 12. Now we do look to combine the like terms that are on the same side. Those are like terms there. That'd be negative 12x. Now this is one of those equations like we've been doing. Do the opposite, get our constant terms together. And finally do some division here. Divide by negative 12 because it's negative. And you would get an answer of negative 3. So the answer for that one would be negative 3. Okay. Why don't you pause the video, try this last one, and see what you get for a solution here. All right, let's see how you did. This one, very similar to the last problem we did. Start by distributing here. Multiply both by 4. Okay, now get your constant terms together by subtracting 12. Okay. Now, when you get to this step, hopefully you did not have what we have here. Don't forget about this little negative sign. That's still with that 20 there. You need to carry that down through. So now we can see it's a negative 20 we need to divide by, not a positive 20, to get our answer. And it looks like we actually get the same solution as the last one of negative 3. Okay. Last thing we're looking at in this section or lesson is how to graph in slope-intercept form. This is something you should have seen in a previous course, but just want to refresh it. Anything in this form where y equals mx plus b, where m and b are numbers, you want to be able to know what those mean. M stands for slope in this case. And slope we can find with 2 points by subtracting your y's and subtracting your x's. So you do that by subtracting your 2 y points of your order pairs over your 2 x points. Okay, the x, remember x in an order pair is always the first number, y is always the second, listed as the second number. Make sure you do the y's on top and the x's on bottom and not the other way around, or your slope won't come out right, because we always define slope as rise, your up and down, over your run, your left and right. So that's why we want y's on top. And b in this equation is your y-intercept. It's the place where your line crosses the y-axis. So on this particular example graph, the y-intercept would be the location right there where it's crossing the y-axis. Okay, so how do we do that? Well, we can do it and find slope by finding the slope from 2 points. So in example 9, if you're given 2 points, first thing we want to do, find that slope, find the m. So here m would be your difference of y's over your difference of x's. You got x1, y1, x2, y2, so subtract the y's on top. Negative 6 minus 3 over, now subtract the x's, 4 minus negative 5. Okay, recall minus the negative, we know we're going to end up adding those there. So on bottom, we will end up with 9. On top, we'll end up with negative 9. So our slope comes out to be negative 1 if we divide those out. Okay, now that's our slope. They wanted us to find a little bit more than slope here because they want the equation of the line. So we also need to figure out what is that b going to be. We can do that by now taking one of these 2 points and substituting that back in. Let's use the first point. Okay, so using our slope-intercept formula, y equals mx plus b, substitute in what we know. This is your x, okay, so that needs to go in for x. 3 is your y, that needs to go in for y. Okay, we don't know what the b is. So putting those numbers in, we found our slope as well. Our slope is negative 1, so that goes in for m. X is negative 5. Only thing we're not sure on is what is b. So now we do a little solving and we can figure out what that is. Multiplying this together, that's 5. And then subtracting, we can find it. So minus 5 from both sides. And our b comes out to be negative 2. Now, we should write out the whole equation here now to do this. And we can get that answer. So putting everything in to our y equals mx plus b form would give us y equals, our slope came out to be negative 1, x plus, and then we found out our b is negative 2, so minus negative 2. A lot of times if this was a standardized test, you'd probably also see this written as, remember 1 you don't have to write, so you could just write that as negative x, and plus negative 2 could also be written as minus 2. So that would probably be the way you'd see it if you had a multiple choice selection to do. All right, pause the video, see if you can do the same thing now for number 10 and find out what the equation of that line is going to be. All right, let's see how you did here. So starting out with finding slope, slope would be difference of y's over difference of x's. And that should have given you negative 4 over 8, which is the same as if 4 goes in 8 twice, so this would be the same as negative 1/2. Okay, so now we got to use that with one of our points to find the b. Okay, so using y equals mx plus b, and let's just take this first point here. Okay, y is 5 in this case. That's our y. Equals m, we found out to be negative 1/2. Our x is the first number, so that would be 4 plus b. And we could have used the other point. The other point would give us the same equation. You don't always have to use the first one. I just chose the first one. All right, now multiplying this out. Half of 4 is 2, but it's going to be negative here when we multiply those. And now to get that over to the other side, it's negative. We want to add 2 to make that 0. So adding 2 on that makes our b equals 7. And so our equation in slope-intercept form would be y equals negative 1/2 x plus 7. So that should have been what you got for that one. All right, last thing, graphing. If you want to graph things that are in slope-intercept form, start with a location and then use slope to get the other one. So here, looking at this equation, we know our slope, or our m, is negative 2. And our y-intercept is 5. I always start with the y-intercept. So on your graph, find out where 5 is, put a dot on the y-axis. And now we want to use our slope to get the remaining points. Slope is rise over run. Now this one's a whole number. Anytime it's a whole number, we think of it over 1, because negative 2 divided by 1 is still negative 2. So negative 2 is our rise, and 1 is our run. Rise, when it's negative, tells you to go down. So we want to go down 2 here, and then over 1 to the right, because that's positive, which would lead us to that location. And then just keep repeating that. Down 2, right 1. Down 2, right 1. Down 2, right 1. And you can continue that pattern forever to get the line. Now you can also go the opposite way to get the other side of the line. So we could also go up 2, left 1, and that would also be a slope of negative 2. Connect the points, and you get the line graphed out. All right, why don't you pause the video and try number 12. All right, so in this one, we got a slope of 1/3. Our y-intercept is -1, start at -1. Here our slope is up 1, right 3, because both numbers are positive. So we want to go up 1 spot, right 3, up 1, right 3. Continue that pattern, or down and left. Connect with the line, and you have the graph of that equation. Okay, try some of these out now on the practice.